For question 8, given that tangent pi over 3 it is equal to sec 3 and then tangent pi over 4 equals to 1. So express the tangent 7 pi over 12 in the form of sec number. So hence use the information of this show that the tangent of 7 pi over 6 is equals to 1 over sec b. This is another sec number here we need to show. So first of all, we have to answer the first part of this question, which is tangent 7 pi over 12 using these two informations. So from tangent 7 pi over 12, for tangent 7 pi over 12, it can be expressed equals to tangent pi 3 over pi 4. You can see as we add up our angle here, pi 3 plus pi 4, we can get it to 7 pi over 12. So we come to a compound angle tangent. So we use the information of compound angle tangent here, where tangent A plus tangent B, our A angle is pi over 3, B angle will be pi over 4. So the formula will be tangent A plus tangent B, then over 1 minus tangent A and then tangent B. Then we plug in our value here where tangent of pi over 3 is equal to sec 3. Meanwhile, tangent pi over 4 is equal to 1. So from this part, we're going to express it in terms of sec number. So you can see our sec number here at denominator. We have to rationalize our sec number. We will time with its conjugate. So the conjugate for 1 minus sec 3 will equals to 1 plus sec 3. So the denominator part here will be a minus b, a plus b. Finally, it will get you a, which is 1 square, minus b. B is sec 3. Sec 3 square will be equals to 3. So for the numerator part here, we will expand like usual. So it will become sec 3. And then sec 3 times sec 3 will get 3. And then 1 times 1, 1 times sec 3. So we can get 4 plus 2 sec 3 over negative 2. We simplify our negative 2 here, you will getting negative 2 minus sec 3. So this is our first part of our questions. And then we move on to the second part of the questions. The question asks us, they say, hence, show this equals to 1 over sec b, means 1 over sec 3, where this is our A and B. So this is our A part, this is our sec B part. So we can see our relationship when we have tangent 7 pi over 6. So compared to the previous tangent 7 pi over 12, you can see actually this is a double angle. When we double angle up for this 7 pi over 12, it will equals 7 pi over 6. So this is our tangent to A, this is our A. So tangent to A, which is 7 pi over 12. So we express our 7 pi over 6, this is equals to 2 times 7 pi over 12 here. So we use our double angle. Our double angle here will be equals to 2 tangent A over 1 minus tangent square A. And we use out our result from the part A, where tangent 7 pi over 12 is equals to negative 2 minus sec 3. So we plug in our value. And then we try to simplify this part until we get 1 over cert b. So we expand this, we will get negative 4 minus 2 cert 3 over 1 minus, expand this, we're using a square plus 2ab and then b square. So here we will get 4, then equals to positive 3, positive 4 cert 3, and then plus 3. So we try to simplify this fraction. We will manage to get negative 6 and then minus 4 cert 3. So we simplify some more. You can see we have common factor here as 2. We factorize the 2. We factorize the 2 here. And it can be simplified. At the same time, we time with its conjugate. So our denominator here is a cert number, so we time with its conjugate. So the conjugate here will be equal to negative 3 plus 2 cert 3. And we need to simplify to the answer as the question asks us to show. So here will be negative 4 and then here is 3. So we expand up there. For our numerator part, it will be equals to 6 and then minus 4 cert 3 and then plus 3 cert 3 and then minus 6. So we can get negative cert 3 over negative 3. So as we see questions here, they want the cert number at denominator. So we have one more step. We time with the cert 3 at the denominator. So from here we can get 3 cert 3. Up here we get negative 3. When we simplify, we manage to prove it is equal to 1 over cert 3. So what is important here, the first one is how we apply our compound angle and our conjugate in order to get to the form of this cert number. That will be our part 1. So for part 2, we apply our double angle and then we do our conjugate and we simplify to the format as the question requests us to do, which is 1 over cert number. So that will be our part A. Then we're going to continue for our part B. They say find the R and alpha such that the expressions of 9 sine theta plus 12 cos theta can be expressed in this form. So this is a R compound angle of sine. Then hence we have to solve this equation for the angle in between 0 and 360 degree. So for the first part, we're going to express out our trigonometry sine theta plus 12 cos theta in the term of R compound angle sine theta plus alpha. So we expand it using our compound angle where sine A plus B will become sine A cos B and then plus cos A sine B. and we expand it fully, it will be r sine theta cos alpha, and then r cos theta sine alpha. So as we compare here, we must manage to get two equations because we need to find two unknowns here. So sine theta compare with sine theta, cos theta compare with the terms with cos theta. So from here we can get our first equation where the coefficient of sine theta is 9. So the coefficient of sine theta means r cos alpha here will be equals to 9. Meanwhile, for second terms here, our coefficient for cos theta will be 12. So the coefficient for cos theta will be equal to r sine alpha. So r sine alpha will equals to 12. That will be our second information. So we have to solve these two simultaneous equations to find out what is our r and alpha. So the way we solve it, we will take equation 2 divided by equation 1 so that our unknown r will be eliminated. And we managed to get to the terms of tangent alpha equals to 12 over 9. So our alpha, we will move our tangent to the right hand side. And then our alpha is in degree. So we can see here our alpha is in degree. So our answer can be 53.13 degree. Then we continue to solve for our unknown r. We will use identity. When 1 square plus 2 square, we can get r square. So we factorize our r square here for both equations. We can get to the identity formula. So when this square, it will equals to cos square. And for this equation square, our r square is already factorized out. So leaving here is sine square. So our value here will be 9 square plus 12 square. So cos square plus sine square, it will be equals to identity. So here will be give us the value of 1. Then we solve for r square equals to 225. So square root of 225 will give us 15. So this is how we find our r and alpha. Then we express it in terms of r sine theta plus alpha. 9 sine theta plus 12 cos theta equals to r, which is 15. Plug in our value, and then sine theta plus alpha. Our alpha is 53.13. So this is our first task. Then we are using our first task result here, hence to solve the equation equals to 5. So we see what is important here. Forming two equations, it is very important by comparison to our terms here. And then we solve these two simultaneous in order to get our answer alpha and r. Then finally express into the r sine compound angle. So here also got 1 mark when we expand. So this is 5 marks for the first task. We proceed to the second task here. Where the equation will be equals to the equation of sine theta plus 12 cos theta will be equals to 5. So substitute our result from part 1. It will be 15 sine theta plus 53.13. So after we substitute this part, we're going to solve this equation. We express it to the format that we want, which is trigo, angle, and we move the 15 to the right hand side. We will divide by 15, which is 1/3. So we get our format of trigo, angle, value. Then we can start our fourth step of solving. So our first step will be talking about range. So the solving range, as the question gives us, is data between 0 and 360. So as our question situation now is not only data, it is data plus 53.13. So it will be add up, become 53.13. The data add up with 53.13. So same goes to 360 here. It will equal to 413.13. So it will be involved one round and more in the quadrant 1. Then we go for step 2. Look at our quadrant here. By look at the value, when we have sign positive value, it will be quadrant 1 and quadrant 2. Then step 3, we go for basic angle. So basic angle, it will be move your sign to the right hand side, it will be shift sign 1/3. So our basic angle reading here is 19.47. So this is our 19.47. So finally, we rotate our angle to the corresponding quadrant. So for 53.13, we will start from 53.13. So this basic angle is 19. So it is lower than the minimum that we want. So we won't get this as our solution. Start from 53.13, which is over here. We start our rotation to quadrant 2. So our quadrant 2, we have a solution here. It will be our 180 minus our basic angle. Then we continue. For quadrant 3, we don't have. Quadrant 4, we don't have. After one round, so maximum we can go until 413.13. So after one round here, it will be 360 plus 19.47. So it is still within our range. So we will take it after one round in quadrant 1. Then it will be stopped at quadrant 1. So no more. So we will see we have two answers here. And we simplify to the simplest data that we want. So we will going to add up this 53.13. When we move up to the right hand side, it will be minus back this 53.13. So this data will give us 107.4 and then 326.34. So what is important here, we can see applying our part 1 answer into the single trigo terms here, that will be our concept, and we need to find our basic angle and find the corresponding gradient with the solution. Then lastly, simplify to the data as the question asks us to do. So here is our nice marks for question 8.